Welcome to this Masterclass Explainer. Today, we're diving straight into what is absolutely the most profound shift in software engineering since we invented high-level programming languages. We are living through a massive transformation right now, and over the next hour, we're going to break down exactly how the systems we use to build software are evolving. We're talking about a total, fundamental reimagining of the developer's role, and honestly, the entire software development lifecycle itself. For decades, programming has really just been an act of translation, right? You understand a business problem, you design a solution in your head, and then you painfully render it into syntax, curly braces, semicolons, endless type annotations. But that era, it's ending. We are moving completely past syntax as our primary interface. We're shifting into an era where we simply express our intent, and we trust intelligent systems to translate that intent into working software. The sheer friction of typing out all that boilerplate is just collapsing.
And I want to be super clear right out of the gate. This is not science fiction. This isn't some distant 10 years down the road prediction that might never happen. As of early 2026, a staggering 85% of professional developers are already using AI coding tools regularly, with over half of them using these tools every single day. On top of that, an estimated 41% of all new code is now AI generated. The future of software engineering has already arrived, and it's literally happening on your team's laptops right now.
So to help you navigate this massive paradigm shift, here is our roadmap. 1. From syntax to intent. 2. Vibe coding versus agentic engineering. 3. Mastering context engineering. 4. The agent harness. 5. The AI-driven SDLC. And 6. Conductors and orchestrators. Let's jump in. Section 1. From syntax to intent. Let's start by looking at how our developer toolset has rapidly evolved to bring us to this precise moment. Think back to just a few years ago, around 2021. We were absolutely thrilled with simple autocomplete, just a basic token prediction guessing your next few characters. Then, boom, we got inline code suggestions completing entire functions. By 2023, chat-based generation meant you could just ask for a whole feature in plain English. And now? Well, while we have fully autonomous agents that can clone repositories, plan out complex architecture, execute code in sandboxes, and submit pull requests with literally zero human keystrokes, we have completely crossed the threshold from human effort to machine autonomy. Which brings us to Section 2, vibe coding versus agentic engineering. Because look, just because a machine can write code autonomously doesn't mean the code is instantly ready for production. There is a massive difference between generating a fun weekend prototype and building highly reliable enterprise-grade software. This brings up a really critical distinction. In early 2025, the term vibe coding went viral. You probably saw it. It basically described a process where a developer writes super casual natural language prompts, accepts whatever the AI spits out, and if it breaks, they just blindly copy-paste the red error text back into the prompt, crossing their fingers for a miracle. Let me tell you, if you're just checking to see if it looks right, you aren't engineering, you're vibe coding. Agentic engineering, on the other hand, relies on formal specs, rigorous automated tests, systematic evaluations, and strict CI/CD gates to ensure low risk and high reliability. But what's really interesting here is that this isn't a simple binary choice. It's a spectrum. The central differentiator across the spectrum isn't whether or not you use AI. We're all using it. Rather, it's how much structure, verification, and human judgment you put around the AI's output. Throwing together a weekend hackathon? Pure vibe coding is totally fine, but a production API handling live financial transactions, that absolutely demands the extreme right side of this spectrum, true agentic engineering, where both the deterministic output and the non-deterministic reasoning steps are systematically evaluated. Section 3, Mastering Context Engineering. So how exactly do we get to that highly reliable end of the spectrum? Well, you have to master the real underlying skill here, which is context engineering. We've all kind of realized that the quality of AI-generated code actually depends a lot less on you writing some super clever prompt and far more on providing rich, structured information. Context engineering requires providing 6 vital categories to your agent. You need instructions defining their role, knowledge like architectural diagrams, memory of past sessions, examples of good, clean code patterns, specific tools like your internal APIs, and hard guardrails for safety. The question you should be asking isn't how do I trick the AI into writing good code? It's what context would a brand new human team member need to actually contribute effectively? And the crucial part is how you manage all that information. You've got to carefully architect the balance between static context and dynamic context. Static context includes your core system instructions and main guardrails. These are the heavy, overarching rules the agent never forgets. They're loaded on every single interaction, which honestly can burn through your token budget faster than a weekend vibe coder. Dynamic context, however, is loaded on demand. By using agent skills, your agent can dynamically pull in deep reference material only when a specific task actually requires it. This keeps your token costs way down and prevents the AI from getting totally confused by an overloaded prompt.
All right, section 4, the agent harness. Because even if you have perfect context, an AI model is essentially useless in a production environment without a carefully designed framework wrapped around it. Think of it this way. Developers often mistakenly treat the raw AI model as if it's the entire system. But the model, it's merely the engine. The agent harness is the car, the road, and the traffic laws that allow that engine to safely reach a destination. It provides the execution sandboxes, the routing logic, and the enforceable constraints that turn a raw, wild reasoning engine into a functional, reliable software agent. And this builds into what is arguably the single most important equation in AI development today: agent equals model plus harness. The behavior you experience with modern coding tools, whether you're using Claude Code, Cursor, Aider, whatever, is dominated almost entirely by this harness. In fact, benchmark tests have shown engineering teams jumping all the way from outside the top 30 up to the top 5 just by tweaking their harness, without upgrading the underlying AI model at all. It's a real game changer. When we look under the hood at the anatomy of the harness, we see it contains your rules, your tool integrations, your orchestration logic, and your observability layers. This is so vital to internalize. When an agent fails or writes terrible code, our first instinct is always to blame the model, right? Oh, the AI's hallucinating again. But more often than not, the failure actually traces back to a missing tool, a vague rule you wrote, or a missing guardrail. Most agent failures you experience are actually your own configuration failures within the harness. Section 5, the AI-driven SDLC. Now that we have a robust harness configured, we can no longer rely on our old ways of working. We have to fundamentally rewire the entire software development lifecycle to keep up with these new capabilities. The traditional SDLC was completely bottlenecked by human typing speed, but with AI, implementation time shrinks from weeks to mere hours, or sometimes even minutes. This shifts the bottlenecks entirely. Gathering precise requirements and making smart architectural trade-offs, those become your new rate-limiting steps. In this compressed cycle, your project specifications actually become your automated evaluation criteria, and your architectural decisions are instantly amplified across the whole codebase by agents doing the heavy lifting for you. Notice the massive shift in the testing phase here, too. Testing isn't just about output anymore. You can't just check if the code compiles or if a basic unit test passes and call it a day. Because AI can sometimes generate fluent-looking code that silently skips vital verification steps, you must also evaluate the trajectory. You have to verify exactly how the agent reached its solution, checking its intermediate reasoning and the exact sequence of tools it called to ensure true, bulletproof reliability. Ultimately, what we are witnessing is developers transitioning into what's known as the factory model. Your output as a developer is no longer the code itself. Let that sink in. Your output is the system, the tests, the guardrails, and the assembly line that produces the code. You are now designing the factory, and the AI agents are the machinery humming away inside it. Section 6. Conductors and orchestrators. As your focus shifts from writing every single line of code to managing this automated factory, your daily role is going to fundamentally evolve into two distinct fluid modes of working. You're going to dynamically shift between being a conductor and an orchestrator. When you are a conductor, you're super hands-on, right there in your IDE, providing real-time, fine-grained control and hitting tab on inline completions. You are actively directing your AI pair programmer. But when you switch to orchestrator mode, you operate at a much higher level. You're defining big-picture goals and delegating complex, asynchronous tasks to background agents, maybe reviewing their pull requests over a coffee a few hours later. The most effective engineers use their conductor mode for rapid, exploratory implementation, but they purposefully reserve their high-level orchestrator focus for what we call the 80% problem. AI can easily write 80% of a feature, sure, but that remaining 20%, the really subtle edge cases, the complex architectural integrations, the deep correctness requirements, that is where your human expertise is absolutely mandatory. You don't try to be faster by blindly accepting everything the AI does. You get faster by focusing your deep, hard-earned expertise exactly where the AI struggles. As we wrap up this masterclass explainer and fully embrace intent as our new interface, I want to leave you with a critical thought. Look at your daily workflow tomorrow morning and really ask yourself, are you still just handcrafting the software, or are you stepping up to build the automated factory? The engineers who realize they are now factory architects are the ones who will completely define the next decade of this industry. Thanks so much for joining me, and I'll see you in the next one.